let's take a look at Chapter 6. So this is the thing they call security assessment and testing, which is, of course, testing your systems to see how well they're working. So access control limits who's allowed to get into systems, and one test is, of course, a pen test. You hire people to hack into your system. They keep notes of what they did, and when they get in, they then submit a report explaining to you what weaknesses they found and how you can fix them. And social engineering is a big part of this. The number one flaw in every network is usually the people, not the technology. You trick the people into clicking a link, installing something, telling you a password, and so on. You might have zero knowledge tests where people come from the outside and are given no particular knowledge about the internal systems, or a full knowledge test where you give them a network diagram and other information. And so they can use a variety of tools to attack you. Popular attack frameworks, Metasploit is the open source framework. We use it a lot in the pen testing class. And Core Impact, Immunity Canvas, and there's another famous one that's used that you can only use if you pay for it and prove that you're a legitimate company. Cobalt Strike is another one that people use. So you plan your attack, you do reconnaissance of the network and the company, then you scan to find out what servers they have and what they have that might be worth attacking. Then you run a vulnerability test to find weaknesses in their system and find some way to exploit the system. And then you make a report of the results so you can tell the company what you found and how to improve it. So pen testers must maintain all the information they learn confidential because, of course, they are learning about the flaws of the system, and that should not be public. So vulnerability scanning, you typically run an automated scanner that just tries to find SQL injection, cross-site scripting, and many other flaws, outdated software, and so on. The scanner itself produces an automated report, which is almost completely useless to the end client because it typically reports hundreds of things and most of them don't matter. You have to go manually decide whether they actually represent a business risk. The scanner will find something, just meaning it got a response from the internet that looks fishy, but most of them turn out not to be real vulnerabilities that will affect the business. And even if there are many of them that are real vulnerabilities, the reason you pay a pen tester is to make a judgment call and help you understand which ones of these are the highest priority, because nobody's going to fix 100 problems. You have to somehow pick a reasonable number of problems that can reasonably be patched with a normal amount of effort and help guide them to whatever's most important. A security audit is another test which does not involve a penetration test where you actually hack into the system. You just have a checklist. Check for all these things. Make sure that the databases are encrypted at rest, encrypted in motion, that there are no two users sharing the same account, that you have the wireless network segmented from the network containing user data and credit card data, and so on. There's a whole series of things you have to have accomplished, and you go through and make sure that they have all been accomplished. And that's what you have for a security audit to make sure you meet a certain level of security, like PCI DSS or SOC 2 or many others. A compliance audit. And so a security assessment will check your network in many ways, like policies and procedures, administrative controls, and so on, to see if you've got these things implemented correctly. You can have an internal audit to make sure that your company is adhering to your own policy, and you can have an external audit, which is typically required by big compliance frameworks like PCI DSS. You're required to pay for an external audit every year from a particular qualified vendor if you have a large number of credit card transactions. I think it's more than 1 million a year, something like that. And then you have to test this external, you have to pass this external audit, and it will have things you're supposed to fix, and you'll have to show that you're in fact fixing them. And another way you can check your access control is by looking at your logs. All your devices make logs, the antivirus, the IDS, the web servers and routers and firewalls and systems and so on. All these things make log entries, and you can examine them to try to find violations of your security policy. By default, systems usually make logs directly on the system. Your router has a place for those logs, your servers have logs, and they're just scattered all through your network. This is almost useless. It's far too much bother to gather the information. So if you want to actually do any analysis of your logs, you want to forward all that log information to a central server that will be running a log aggregator like Splunk, gathering all the data in one place, putting in a database you can query from one location, so you can search through what's been happening and all your logs are put together. Syslog is an old system to do this. It's still used, that sends data over UDP 514. There are other many other ways to forward the data. There are Splunk agents to particularly forward it to Splunk for basically every piece of hardware and software you can buy. So then you can consider how to test the software you write. Your company writes software, and you have to have testing to make sure that it functions well enough and that it's secure. So you can find the errors. Now, custom apps won't have a vendor providing patches. It's up to you. If you write your own app, you've now incurred technical debt of maintaining your app. You're going to have to detect its flaws and fix them. That's why when I worked at a financial company and the boss found me writing code, he told me, quit writing code, use standard products like Microsoft Office for this reason. Because if I made custom code, we would have the obligation to maintain it. So that should be avoided if there is a standard commercial product we can use instead. So you can review the source code of the code you write, and there's various two basic ways to do it. Static and dynamic analysis. Also, manual code review really should be 3 here. In agile shops, you have pairs of programmers working together, watching each other's data while they're planning and writing code, watching each other's actions. So static testing is where you test the code that is not running, typically by reviewing the source code. You run programs like lint, and I think Checkmarks does this. There's a bunch of programs that will run through the source code and find dangerous patterns of behavior. Typically, the thing it finds is a place where user data is used without sanitizing it first, but many other things. So it'll warn you if it finds flaws in your source code. Then you can do dynamic testing where you actually run the app and then dynamically send requests to it like a user, trying to operate it from a scanner like OpenVAS or Nessus, and it will try to find if it can make the send inputs which have dangerous outputs, indicating things like SQL injection, cross-site scripting, and many, many other flaws. So again, you've got white box testing where you have the source code and black box where you don't have the source code. So you can map customer requirements to the software testing plan. This is called traceability. And you can have synthetic transactions, which is very common. You have web apps, and you have a list of transactions. I'm going to execute this command, and that should succeed in logging in. That should be rejected for logging in. That should succeed in purchasing a product. That should fail in purchasing a product, and so on. A whole series of tests, synthetic transactions you run to see if they're processed correctly. So unit testing tests the individual components one at a time. Installation testing tests it as it's first installed. And integration testing tests multiple components as they're combined into a working system. And of course, you want to do all these things. Regression testing is really important. After you make an update, you should have a regression test that tests all the normal functionality to make sure it still works. This is what's been spectacularly failing at Microsoft. Microsoft, once again, has said the latest Microsoft update causes blue screen of death. It causes Azure machines to freeze for half an hour and so on. Microsoft seems to extremely fail at regression testing. They keep on putting out updates that break important functions. Anyway, I'm not necessarily saying they're stupid. The problem is Microsoft software is used everywhere and installed on a variety of hardware, and along with a variety of other softwares that might impact it. So probably they do some testing, but they do not have enough test conditions to capture all the conditions their users are experiencing. And then there's acceptance testing, which means making sure your software meets the customer's requirements. All right. Fuzzing is a type of black box testing where instead of just sending planned inputs, you just send random inputs. The original one was to use a dial-up modem during a thunderstorm that caused random bits to flip. You send data with errors in it to try to see if you can crash the program, and that's one way to, and this has found many flaws. It's now considered part of any software development process should include fuzz testing because in the time of Windows Vista, Microsoft was greatly humiliated. After they tested their code with the other techniques, like source code scanners, people that were doing fuzzing were able to find fatal vulnerabilities in Windows in just a few seconds of fuzzing. So most people have decided that you really have to have a considerable amount of fuzz testing before you put any software out in the market, because it will find flaws that you don't find with other techniques like source code review. Then there's combinatorial software testing, where you try to consider combinations of inputs. So even if every individual input is handled correctly, there may be a combination of inputs that cause it to have the wrong result. And you can do misuse case testing, where you try to model an adversary trying to misuse your application. Another way to do it is threat modeling, which Microsoft does in their security development lifecycle. They have a stride model with particular categories of threats, and you consider how each of these threats will attack your application. So one problem with all testing is it tends not to cover all the code base. If you do fuzz testing or scan with a vulnerability scanner, you're only feeding inputs in where the user input goes, and that only touches a small part of the code. There's a whole bunch of code that isn't actually involved in processing user input and may not be tested. So this is a big deal. I know if you get the Peach fuzzer, you can actually modify your source code by putting hooks in it, and one thing it can do is more thoroughly cover all the code. Is fuzzing kind of like old phone phreaking with whistles? Well, phone phreaking with whistles actually works by sending a signal that was an expected signal. The touch-tone phones actually send sounds, and the sounds are what codes for numbers, and there were certain sounds that coded for like an operator testing a line. That was what the whistle was. A fuzz testing is just random, though. It's sending random inputs, which will happen to change bits, and if there's flaws in the code, it'll misunderstand them and have unusual effects. So the whistles were not random, but fuzzing is random. That's one reason why Microsoft resisted it. If you're doing fuzz testing, you never know when you're done. You send random stuff for 12 hours, but you really haven't tried all possible combinations. That would take forever, so should you do it 24 hours or longer? How long should you do it? And nobody really knows, but now some degree of fuzz testing is considered standard. So when you're done, you got to have a report. So you have to analyze what happens here, like the security test results you can produce by just running a scanner, but then you have some document listing a bunch of technical flaws. You have to then analyze it and decide how does this really affect the company and what should the company do to fix this problem. It's very much, I often compare it to medical tests. You go to the doctor to give you a blood test. They give you a list of like 14 things about your blood has this much of that and this much of that, and what does all that mean? You need a doctor to help interpret it and say, well, here's what it means and here's what you should do about it. It's the same thing. All right, so let's try Kahoot, Chapter 6. I guess I have to open them. There we go. Oh, I should change the size so the number doesn't get cut off. Okay. All right, looks like that's it. All right, so which process would ensure HIPAA compliance? Yep, a compliance audit, comparing your systems to the requirements. All right, what process goes on UDP port 514? That's used to forward log information to a central server. It's the old-fashioned syslog, one of the earliest systems used for that purpose. All right, what process takes place after you update software? Regression testing to make sure that your software still works correctly for the things you need it to do. All right, and what does Microsoft highlight in their software development system? Software development lifecycle. Threat modeling is what Microsoft pushes. All right. Kuna will have to tell me who they are if they want to keep their points. The others I think I know. All right, so let me stop this recording.